putting the intermediate value theorem into action is basically doing what the zero finder comprehends for us on the graphing calculator. The zero finder, you remember, tells us what value of x causes the function to be equal to 0. It's kind of what we're looking at here with example number 24. We're asked to find or prove that there's a solution on the interval from x equals -1 to x equals 0 for our function g right there. So what we're basically looking to do is saying, well, if the function's continuous, and this function is continuous because it's a polynomial, then if we just find the value of the function at the left endpoint of our interval and at the right endpoint of our interval, and it turns out that one result is positive and the other result is negative, well, the intermediate value theorem says you cannot go from a positive number to a negative number unless you hit all the numbers in between. One of the numbers in between is 0. So therefore, there has to be a spot where g of x equals 0, where g of x has a solution somewhere in between these two values. So let's see if it works out. We need to find g of -1 and g of 0. G of -1 will be 2 times -1 squared minus 4 times -1 cubed. And we know that -1 squared is 1, and -1 cubed is -1. Plus -1, goes minus 1, minus 1. All right, so we have 2 minus 4, excuse me, plus 4, because of the double negative. So that's 6 minus 1 minus 1. That gives us a total value of 4. So g of -1 is 4. What's g of 0? That's actually rather easy to comprehend. 0 minus 0 plus 0 minus 1. Okay, 0 plus 0 minus 1. That's -1 right there. Okay, so look what happened. G of -1 is 4. G of 0 is -1. G started the interval positive, but finished the interval negative. It had to have been equal to 0 at some point in between -1 and 0. That's what the intermediate value theorem does. It guarantees that these things happen. Doesn't tell us where. We would still have to find that out through another method, using our algebra skills. But it's got to happen, according to the intermediate value theorem. Because again, what was the key thing? The function's continuous, and the value of the function at the beginning is different than the value of the function at the end. If those two things are true, then the intermediate value theorem comes into play. Let's look at example number 25 now. We're given a different function f. We don't know what the formula is for f, but that's okay. We know that f's value at x equals -4 is 3. F's value at 0 is 1. F's value at x equals 2 is -6. And based off of this data and the fact that the function is continuous, we have 4 yes or no questions concerning the intermediate value theorem. The first one states, does the intermediate value theorem guarantee that the function is going to be equal to 0 on the interval from x equals -4 to x equals 0? Well, at x equals -4, the function's value is 3. At x equals 0, the function's value is 1. Started positive, ended positive, it's above 0, it's above 0. No, the intermediate value theorem says it might happen, but we don't guarantee it's going to happen because 0 is not between the 3 and the 1. So the intermediate value says I cannot guarantee it. How about for part B? Does f equal -5 on that same interval? Well, again, -5 is not between 3 and 1. So the function might equal -5, but the intermediate value theorem does not guarantee it. So this would also be a situation of no. Now, had part B said, does the function equal 2? Well, 2 would fall between 3 and 1, so the answer would be yes. Okay. Look at C. Does f of c equal 0 on the interval from 0 to 2? X equals 0, our function is 1. At x equals 2, our function is -6. Our function was positive. It became negative. It's continuous, so it has to hit all the values in between. 0 is a value in between, so this will be yes. And finally, how about on the interval from -4 to 2, will the function equal -5? Well, at x equals -4, the function's value is 3. At x equals 2, the function's value is -6. -5 is definitely between 3 and -6, so this will be another yes. That's how the intermediate value theorem works for us, as long as the function is continuous and the starting value and the ending value are not the same.